Hey guys, for this project, we're going to do three things, well, two and a half things, two things. We're going to make purple procedures blocks that the first one is going to search for a single letter in a longer sentence, okay? Remember, these are purple procedures, or user-defined blocks. We're going to send it two pieces of information. We're going to make a block that accepts two string inputs. One is a longer phrase or a big word or a sentence. The other one is a letter to look for in that sentence. If we find it, we're going to say, found your letter A in your sentence, blah, blah, blah. Oh, you know what the heck? We're going to count too. I want to do that as a second one. So we are going to do three things. And then the fourth thing, the fourth thing is going to be optional, okay? A chance for you to earn a piece of candy if you show me a completed version of it. All right, so for those who want to work ahead or work faster, let's quickly make sure you understand what the three things are. Search for a single letter in a longer sentence. Count all of a certain letter in a sentence. In other words, count the I's in Mississippi or the A's in Flappy Dappy Mappy Schmappy. There are 4 A's in that sentence, by the way. Mississippi has 4 I's and 4 S's, I think. Okay. So again, one block, 2 string inputs. One is the sentence, the other one is the letter you're looking for. This one searches for it. This one counts the number of that letter. Okay. I think those are good basic search things that are useful for beginners and not too hard. The harder one we'll talk about in a second. The third one you're going to do is splitting a string up by a special character. Okay, first year we did this. This year we tried to do a little AI chatbot that could look at our words. Like if I said, "What is your name?" it would look at each word and say, "Oh, what is your name? Oh, I know the word name. You must want to talk about names. My name is Chatbot." It was kind of frustrating because the user had to type one word at a time and hit enter. A, enter. Dog, enter. Eats, enter. Me, enter. Thought that wasn't a very good idea. So instead, well now, we're probably going to have that assignment after this, a chatbot assignment after this unit, and you're going to basically take a string, some string, like a dog eats me, and a special character like the space or periods or commas or the letter I, and you're going to chop up that sentence, that string, and put all the words separated by spaces, in this case, in parts of a list. And then on this, another example is Mississippi by the letter I. We'd get an M, ignore the I, SS, ignore the I, PP, I. And when you're finished, place this in your backpack. We will use it for our chatbot in future years. So the fourth one is a bonus. You're going to create a search block that searches for a small string within a larger string. Okay. So this one searched for the letter K in I like turtles. You're going to search for the word Ike or the word turtle in the sentence. Okay. It's a bit harder. And a hint I give you is that you will probably, another example, you're going to look for lazy in a quick brown fox jumps over the lazy dog. One thing you can't do is I don't want you to get candy for this. I don't want you. Let's see. Yeah, I don't want you using lists. Okay. The split thing puts things in a list, and then it gets real easy because lists have a thing called contains. You can see if the list contains dog. I want you to use at least 2 loops, nested loop inside another loop, to search for the individual letters. And I'll give you one more hint. In this sentence, a quick brown fox jumps over a lazy dog, we can only search for the letter one letter at a time, right? We can't look for big words. All the string stuff we have is these 3. Join, certain letter of a word, and length of word. We probably won't use join. We're going to use these 2 and loops to accomplish this, okay? And let me just give you one hint. If you're looking for oyster? I don't know. If you're going to look for my in a sentence, you can't look for my in Scratch. You're going to have to look for the letter M. You're going to have two for loops, one of them going through this, looking for the first word of the magic word. I'm sorry, you're not going to use length of this. Anyway, that's kind of your hint, is you're going to have two for loops comparing one letter at a time. Okay, that's all the hint I'm going to give you because it's kind of hard to do. I've already talked for, what, 5 minutes? Gosh. Let's get rolling on this project, okay? Okay, so for the first one, search for a single letter in a longer sentence, pause it, see if you can do it. I just talked kind of about how to do it. We're going to use these two blocks. That's what we're going to use a lot here. And we are going to create a more block. We're going to make a block. I'm going to call this search for, and see, I'm going to try to make this pretty obvious what it does without even having to look at the code. Okay, that's kind of one huge point of making these purple blocks. Okay, and while I'm at it, let's talk about some other points of the purple blocks. I'll say this in the next video too, because people probably didn't get this, but it's about reusability. Okay, let's see if I wrote this down somewhere. I thought I did to give myself a reminder. These purple procedure blocks should be black boxes to us. We don't necessarily have to understand 100% what goes on inside them. Well, if we write them, we do, obviously. But when we use black boxes, everything's hidden from us. All we know is what it does. Okay, so in other words, I'm going to search for letter in, and I'm going to put another string in sentence. Okay, these are my two variable names, letter and sentence. You can choose whatever you want, obviously. But this is a nice block that just makes sense. I'm going to search for an M in, maybe I should say in the sentence. Search for M in Mississippi. I'm going to search for, let's not do Mississippi. Let's do rats are clean if they shall. I know, something shorter. Rats are clean. Okay. And let's search for a C. And you see right there. Okay, I see it. It's there. How do you get the computer to see if it's there? Okay, so we're going to try to run this. And if it finds it, it's going to say, hey, found your letter C in rats are clean. Okay. Using these blocks and some kind of loop. Okay. See if you can go from there. Pause it. Get this laid out. See if you can figure out how to define search for a letter in a sentence, okay? And the other point of this is not just black boxes, it's code readability. This makes a lot more sense than seeing the loop. Seeing these loops, you're like, what the heck does that loop do? I don't know. And you're saying, well, I could right click and comment it, or I could make a broadcast with the right message, but neither of those lets you send information in, which leads me to my next point. These are also recyclable. Look for a D in McDonald's is yum. I don't know, something like that. Look for a Y in it, okay? And you see right there, oh, there's a Y. And maybe, yeah, technically we should probably make it say I didn't find it if it makes it all the way through. I don't know if we'll do that. Yeah, we will. But we need to get rolling on this, okay? So the last thing is, yeah, recyclability, reusability, that it's not just for one letter and one word, one sentence. It can be used for any letter in any sentence, okay? And that's probably the most powerful thing about these purple procedures or user-defined blocks. Let's go. Pause it, try it. We're going to repeat until we get to the end, or repeat a certain amount of times. It's kind of your choice. But let's just go. Let's go look at one letter. Okay, maybe that's easier. We're going to look at one letter. Let's look at the first letter. Is the first letter a C? Well, let's go see. Letter one of, oh, what are we going to do here? Okay, I'll put this to the side for a sec. How do we get that? Do we have to type that in? Rats are clean? Well, if we do, we just made our purple block useless. Okay, the whole point of this is see if you can find it. We're going to search for, look at letter one of sentence, and that's a 0 right now. Let's run this. Oh gosh, how do I do this? Oh, I need to hook it up. Sentence is not meaningful right now. What's in sentence? A 0, that's why. Okay, so I need to do this and have it say letter one of sentence. Okay, that should work. Run it. There we go. R. It found the R in my sentence. How did this happen? This is kind of complicated, but search for blank in blank. Well, what are these blanks? It's a C in rats are clean. This C went where? and let's make sure we understand this. When my program ran, this purple block runs and it jumps over to the definition. And I can change the definition, right? So when it jumps over here, it sends this C, and this rats are clean, to these two slots. C is in the letter slot, and rats are clean is in the sentence slot. Okay? So now let's go say letter, just to make sure we understand. Okay, sorry, let's run it from here. It's not getting, there we go, C. Letter is C, and sentence we already saw is rats are clean. Okay, so you got to make that connection there. This goes in the first thing. This goes in the second thing. If I had a third thing up here, it would go in the third slot over here, but I don't. And now, instead of saying the letter, we're going to look. We're going to say, hey, let's check that first slot. If that first slot is a C, when I say is, what do I mean in math class and programming class? Equals, okay. If letter 1 of sentence equals, well, a C, and what is sentence right now? It's 0. It goes to 0 every time. I don't like that. It resets. You have to go through by clicking the green flag to test this, okay? So let's go plug it in. If letter 1 of sentence equals a C, and remember, if this is easier for you, get rid of this for now. This is rats are clean. It's easier to figure out a solid, hard values like rats are clean and C, and then plug in variables. Sorry, I kind of cut corners. But yeah, letter 1 of rats are clean, you know that. It's R. Does it equal a C? Well, that's false. Let's make one that's true. Let's go cats are clean. Oh, I like that. Letter 1 of cats are clean is true. Okay. Okay. Now, instead of, well, and let's have it say something. Sorry, say, well, if they're equal, we found it. Okay, found your letter. And at the end, I want to join these and say found the letter C in rats are clean, or found letter in sentence. Found the letter in your sentence, okay? We'll do that at the end. Are you ready for this? Are you ready to, so you might think, okay, I'm going to start duplicating these. I can do this. I can say if letter 2 is a C, if letter 3 is a C, then, and that kind of works, okay? There's two problems, and this is probably the, if you will pay close attention here, you'll understand this. Do you see a problem with this? Why can't I just have a bunch of ifs? And let's plug this in. We got to do this right. This is my sentence, and this is my letter, okay? Does that make sense? Sentence is rats are clean. And the letter is not a R or a C. It's whatever letter I'm sent, because in a minute we're going to search for a Y in McDonald's is yum. So that's one big jump, is connecting this solid sentence to these variables. The other big jump is to understand why we can't go if letter 1 is that, if letter 2 is that, if letter 3 is that, if letter 4 is that. Remember, this is letter 1, this is letter 2, this is letter 3, this is letter 4, this is letter 5, this is letter 6, right? The problem is that we can do this for any sentence. And you say, well, I can put 100 of those in there if letter 100, and you know, maybe if it doesn't exist, then I'll just ignore it. But some jerk is going to come along and write a sentence that's 101 letters long just to make you mad. Okay, that's how programming is. You always, somebody will find a bug in whatever you think of. So we need to have this work for any size sentence, whether it's just rats or cats or rats are clean. And the thing about that is we don't know how long it's going to be before the program runs. And you're like, well, because I typed this in here, yes, I do. I know this is 10 or whatever letters long. But eventually our program needs to work for user input, right? Give me a letter, give me a name, and I'll search for you, okay? So do you see how this, I hope you understand why this doesn't work good enough. And secondly, I hope you see a pattern here. We're going to search at letter 1, letter 2, letter 3, letter 4. Hey, we've done this before. We have found some, we've had a loop that can change numbers, that can print numbers. We've done that before, a few times, okay? So let's put these down for a sec. Let's get our loop out and repeat 10 times. Remember, one problem of Scratch is that this number here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, can't be used here. I need to go to data. See if you can figure this part out, okay? I know you can if you try. And if you don't try and you're not having fun, please get your math credit from accounting next trimester. I know that this is not games, but this is a game to programmers. Solving problems like this is one of the most basic but interesting or a little bit difficult problems programmers do, okay? All right, so we don't repeat 3 times. We don't repeat 4 times. We don't know how long the sentence is. Or do we? Is there something here that tells us how long a sentence is? The length of a sentence? Yes, there is, Mr. Grammar. Okay, and you should have tried this already. Repeat not length of word, not length of hide, not length of rabbit. Length of rats are clean, but it's not always rats are clean. It could be any other sentence. So I need to length of my sentence times, okay? And here's the deal. We still don't have a way to go 1, 2, 3, 4, 5, 6, 7, 8, 9 letters in this. We need to make a counter variable, okay? And I'm going to call it counter, but you can call it, usually in programming we call it I actually, or J or K, some single variable name. But before this runs, we're going to set the counter to, where do we start? So we're going to start in slot 1 in Scratch. And I'm going to throw all these away, okay? Remember, the counter needs to start at 1, and then go 2, and then 3, and then 4. So what needs to happen to counter every time this loop repeats? Well, it doesn't need to get set again. It needs to grow a little bit. It needs to change by +1 after we look inside the loop, okay? So, in other words, let's go say the counter, just as a quick review of what the counter variable does. And I'm going to get rid of all that other stuff for just a sec. Play. 1, 2, 3, okay? And how long is my sentence? Well, let's find out. Let's have this not talk for quite so long. 6, 7, 8, 9, 10, 11, 12, 13, 14. Whoa, 14. That doesn't sound right. 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, I thought I was smarter than the computer. Okay, so we don't need to say the counter. I was just testing it. But that is a counter variable that can go through all the slots. One of the hardest things we do in programming. Hardest to understand. But if you understand this now, you should maybe consider continuing on in programming. If this is fun at all for you, definitely consider going on in programming. If you don't quite understand, you can wrestle with it and get stronger. But if you're the kind of person who gives up the wrestle and refuses to try, copy my videos and take accounting next try. Anyway, set counter to 1, or come after school, get more help, raise your hand, ask a question. Those are all good ways. This video is getting long. This is going to be the only thing we do, but we are going to continue on in the next video with the next assignment. Okay. So I think I'm close to being done. Let's try. I actually didn't read it that close. I can see a problem already. Let's hit play, and let's search for a C in rats are clean. Nothing happened. It didn't say anything, so it didn't work. Can you see what happens? We're repeating 14 times. That's the length of the sentence. Let's trace that 100%, okay? Green flag click. Search for my C in rats are clean. Well, that jumps over here and sends C into letter and rats are clean into sentence. My counter starts at 1, where the beginning of a sentence. Repeat length of sentence, or 14 times. This length of sentence is 14, if we could test it again. And then for each slot, jumping through all the slots, that's what the repeat length of sentence and then changing the counter does. It starts at 1, 2, 3, 4, 5. Counter equals starts at 1, and then it grows by 1. It goes to 2, up to length of sentence, which is 14. And then all we do is every slot, every letter, check and see, hey, if the current letter, this checks letter 1 every time. This 14 times checks if letter 1 of the sentence is my secret letter, my letter I'm looking for. Do we want to check if this R is a C 14 times? No. What letter? Not letter 1, not letter 2. Yeah, well, yes, letter 3, letter 4. But what did we create that could jump through all the slots? Pause it. Tell me. Say it out loud. We created a counter variable that could do that. All right, let's run it. Found your letter. Okay, and I'm going to join some words here. I don't just want to say join your letter. I want to say 3 things, actually. I want to say found your letter. Ooh, maybe even 4 things. Found your letter in slot. Ooh, I like this. This is good. Pause this, do this. We're not going to say found your letter. We're going to say found your letter C in slot blank, sorry, and I didn't quite do this right, in slot blank of, oh, this is good. Do you know what I'm going to say here? Found your letter C in slot 1, 2, 3, 4, 5 of rats are clean. Can you finish this off? Please do. Like, I can't make you. I guess I could make you. We could have more tests, but pause here, hit pause and finish it off, and then I'll quit talking. We'll start the next video. Found your letter C in slot duplicate counter of, ooh, oh, I forgot an of, got to do one more join. This is a lot of joins. Do I have to pull all these out? Maybe I do. Nope. That of should be able to go right there. I don't know how to, there we go. That's a lot of joining. You don't have to do all that, but I like it. Okay, let's run it one more time. Found your letter, oh, sorry, exclamation, found your letter, exclamation, that was not my letter. I'm going to put spaces here, before and after, to get some good spacing in there. In slot blank of needs a space on both sides of it. I like this. Found your letter C in slot 10 of rats are clean. And I would put quotes around it just so you know that rats are clean is a sentence. But let's run it again and let's swap these out. Found your letter Y in slot 14 of McDonald's is yum. Is that right? It looks right. Use your own, do a couple more, duplicate this. Do your own stuff. Found, search for D in the rabbit is clean. Ooh, I like that. And let's just do that one. Nothing happened. What about B? Found your letter in slot B in slot 7. Ooh, found your letter B in slot 8. I found 2 letters. And that's going to lead us into the next project, is to count the amount of letters in a string. Okay, and I think this is good enough preparation that you should be able to do that. One thing you could do, one thing you probably should do, is ask the user, give me a sentence. And I'm not going to, this is getting a little bit long, but I want you to finish this off. Ask them for a sentence, and then make a variable called sentence, and then ask them for a letter, and make a variable called letter, and then call search for blank search for letter in sentence with their stuff. Okay, and then it works for any sentence in the world that they choose. And now my program is useful to lots of people and not just me for 1 sentence or 2 sentences. Okay, all right, I'll stop there. That's a good stop, about 20 minutes, I think. I really want, 23 minutes. I wanted to get more done, but we'll do the rest in the other videos. Thanks for watching. And finish this off. I do that ask and give it a try. Thanks, bye.